Hello students, today we are going to discuss our last compound or last topic of group 16A. This one is sulfuric acid. Okay. Now sulfuric acid is a very strong acid. Okay. Now how can you prepare sulfuric acid? We are discussing only one preparation method, which is the most important and used in the industrial scale. See, preparation of sulfuric acid involves the following steps. First step is the burning of sulfur in air. Burning of sulfur in air. Burning of sulfur in air. Air means oxygen. Okay. That means sulfur is burned with oxygen. That means it produces sulfur dioxide. Okay. Next. Second step. This sulfur dioxide, which is produced in the first step, is again react with oxygen in presence of some catalyst and some appropriate condition. So, when 2 moles of sulfur dioxide reacts with O2 in presence of V2O5. See, this one vanadium pentoxide is act as a catalyst to carry out the reaction. And another condition is pressure is of 2 bar and temperature is suppose low temperature. You can give low temperature, and we got 2 moles of sulfur trioxide. Okay. Now see this one, vanadium pentoxide, pressure and low temperature is the important conditions to carry out the reaction. If this step does not carry it, then obviously the H2SO4 will not form. That means we can say this condition, that means presence of vanadium pentoxides and pressure and low temperature is the necessary conditions for the preparation of sulfuric acid. Next step. This sulfur trioxide reacts with sulfuric acid. Okay. Sulfur trioxide react with sulfuric acid H2SO4 and produce what? Produce another acid H2S2O7. H2S2O7, and this acid has name as I am said. Okay. Now this acid is known as oleum. The name of this acid is oleum is very important. Okay, you have to remember this one. Now this oleum is nothing but the sulfuric acids. Why? Because when it reacts with water, or you can say when it hydrolyzes with water, it produced 2 moles of sulfuric acids. Okay. Now see how. Suppose it hydrolyzes with water, then it produces 2 moles of sulfuric acid. Remember one thing, to produce sulfuric acid, we need sulfuric acid. That's why we are giving 1 mole, we are obtaining 2 moles. Okay. These are the proper preparation method for the H2SO4 in the industrial scale. Okay. Now see its important properties. See properties. First properties. First property is that its low volatility. It has low volatility. That means it does not volatile. Simple meaning. Now what do you mean volatile? Volatile is the property of any chemical by which it's evaporated at the room temperature. Okay. Second property is the strong acidic character. Strong acidic character. How? Now see, we are writing the dissociated sulfuric acid. Suppose this one sulfuric acid. When it reacts in presence of water, it produces, first of all it produces SO3 negative plus H3O positive. That means one hydrogen is transferred, that means one proton is transferred to water to produce this hydronium ion. Okay. Now see here the dissociation constant, we are writing Ka1. K means dissociation constant, A for acid and 1 means for the first hydrogen. That's why Ka1. It is obtained that more than 10, which is very high. Next, when this is SO4 negative again dissociated with water, it produces SO4 2 minus plus H3O positive. Here the dissociation constant A2, that means this 2 for second hydrogen, it is found that 1.2 into 10 to the minus 2, which is very low. It is very low. Now why it is high or why it is low? The question arises. The reason of that, due to the negative charge in these spaces, this species has less tendency to donate further hydrogen to produce H3O positive. See, this is also an acid. Acid means it should have the tendency to lose the proton. That's why it loses proton, no doubt. But due to the negative charge, it has a little tendency to produce proton. That's why this one has the Ka, that dissociation constant value is low, but here is high. Now as we know, more the dissociation constant value, more the acidity. Okay? We can write here also Ka, dissociation constant, is directly proportional to the acidity. If it increases, it also increases. If it decreases, it also decreases. Okay, that's why here it is the most acidic, but it is little bit less acidic. Okay, this is the main reason behind that. Now see next properties of sulfuric acid. Okay, third properties I am writing. See, the third property is the strong affinity towards water. With strong affinity towards water, in other sense you can say act as a dehydrating agent. Now what does it mean, strong affinity towards water and act as a dehydrating agent? Now see, being a very acidic nature, the sulfuric acid has a strong affinity towards water. That means the acid, sulfuric acid, wants to react with water. In other sense, if it is react with water, then the species in which the acid is reacting, from that acid the water will remove. That means the acid act as a dehydrating agent. That means removal of water from the species in which the acid is reacting. Isn't it? Okay. Yes. Next property. Next property is it is a strong oxidizing agent. Strong oxidizing agent. Strong oxidizing agent. That means it oxidizes, other itself get reduced. Now see some example. Suppose copper is react with sulfuric acid. Then obviously it is concentrated. Then it produces copper sulfate plus SO2 plus water. Okay, here 2 moles of water. Now see, here copper is zero oxidation state, but here is 2 plus 2. That's why copper is oxidized. By which? By sulfuric acid. That's why it acts as a oxidizing agent. Okay, let us take another example. Suppose we are taking another example with 3 sulfur plus 2 moles of sulfuric acid concentrated, and it produced 3 moles of sulfur dioxide plus 2 moles of H2O. This is the oxidation of this one. Here it is 0 plus here it is plus 4. That's why it is oxidizes. No, if it oxidizes by which? By this one acid. That's why acid acts as a oxidizing agent. Okay, let's see some other important properties is. Next properties. Next property is suppose this one. It should be number 5. No, number 5. H2SO4 can form 2 types of salt. 2 types of salts. One salt is neutral. The another type is acidic salt. First salt is neutral salt, second salt is acidic salt. But how? See, first example of this one. When 2 moles of sodium chloride reacts with 1 moles of sulfuric acid, then it produces what? It produces 2 moles of HCl plus sodium sulfate. See, it is neutral. There is no any acidic or basic character in this particular salt. Not this one. This is obviously acid. But we are not dealing with this acid. We are dealing only with the salt. That's why it is neutral salt. But when 2 moles of 1 mole of sodium hydroxide it react with 1 mole of sulfuric acid, then it produces different types of salt. NaHSO4 plus H2O. Now see this one only. This is a salt. Name of this salt is sodium hydrogen sulfate. In some cases it is written as sodium bisulfate. Okay. Now see, when sodium hydrogen sulfate is react further with water, it can produce a proton. If it can produce a proton, that means it will act as an acid. That's why I am said acidic salt. Okay. This one, if it reacts with water, it can produce NaSO4 negative plus H3O positive. This H3O positive is the responsible for the acidic character of this salt. That's why we can say When acid react with the sodium hydroxide, it produces acidic salt. That means sodium hydrogen sulfate. Okay, clear now? Okay, I think clear. Let's see some uses of sulfuric acid. Uses of sulfuric acid. Uses. First uses, it is used in petroleum refinery. Petroleum refinery. Refining, okay. Petroleum refinery. Second use is the manufacture of pigment, dyes and paints. Manufacture of pigments, dyes, paints. Third usage is suppose in detergent industry. Suppose fourth point is as a oxidizing agent, or you can say manufacture of fertilizer. Suppose I am writing manufacture of fertilizers. Okay. These are the most common uses of sulfuric acid. Okay, let's finish today's class. Next day we will start in our class. We will start group 17 element. Okay, thank you.